All right, guys, welcome to another exciting video from Mr. Slagle's Mathnasium. Today we're going to be learning about something called pulse width modulation, or PWM for short. If you want to see a great video, I don't feel like super comfortable playing this inside my current video, but if you want to see a great video in your own time, check out this channel, YouTube channel. This guy has created something called the Flopatron. And basically how the Flopatron works, it's controlled by an Arduino, which you can see in the video, but it's hard to see right there. There's your board. And he can control individual circuits with that Arduino. And he is doing so to get these, like, I don't know if these are printers or something, and these floppy drives and these hard disks to operate at different voltages. And what that does is when these disks get up to speed, or these motors move, they create a little sound, kind of like the 3D printer in the back of our classroom. And so he's got it all tuned, and he has it play different songs. It's a cool channel, and he is using pulse width modulation to do so, to control the different speeds that the motor is going, all the different motors to make a song. So check that out, the Flopatron. You guys are really going to like it. All right, we are going to get into pulse width modulation. On one of the exercises today, though, you will need to remember, and you probably will need to use this thing called so before we get into PWM, you're going to have to use this thing called the Modulus Operator today. And the Modulus Operator just represents the remainder of division. So if we were to do 5 divided by 2, 5 is not divisible by 2, and so we get the remainder of 1, right? We can do 2 times 2 is 4, 5 minus 4 is 1. We have 1 left over, so that has remainder 1. How about 17 mod 5 is how this is read, 17 mod 5. Well, I can do 15 divided by 5, and 17 is 2 away from 15, so this is 17 mod 5 is equal to 2. Okay, how about 26 mod 7? Let's see here. Well, you would go up to 21 is the closest multiple of 7, which means 26 minus 21 is remainder 5. So you can go ahead and pause the video, practice these ones, tell me what you think the answer is, and then verify when you got it done. Okay, let's see here. 9 times 4 is 36. So this would be remainder 2, 18, 16, that's remainder 3, and 8 mod 2, well, 8 is divisible by 2, so you get remainder 0. So how can we use this in our program? Well, the program is asking you to decide whether or not something is divisible by 2. So I want you to look at the numbers that are present here and see if you can get that figured out. I'd also like to do a review of for loops. So it says, how many times does this for loop run? For x equals 100. Okay, and then it's going to loop and then check and then continue. So how many times is this loop going to get the light to blink? So we're changing the blink speed with a for loop. The first loop is at 100. It'll run with x equal 100 because 100 is less than 1000. On the next loop, so it's going to run through, do a delay of 100 milliseconds. It's going to increase it to 300 and double check. 300 is still less than 1000, so 300 will run. Okay, and then the next one is going to increase to 500, and 500 will run, so we're at 3 loops. 700 will run, 900 will run, and the next loop will be 1100, which will not run. So we're looking at 5 full loops or 5 full blinks for this program. Okay, and remember, here's a little if statement review. What is this program going to do? Which lights will be present and on? Take a guess, and I'll go ahead and describe it now. If x equals 5, is 5 greater than 6? It is not, so that will be off. It's not going to turn this on. Is 5 greater than 10? It is not, so that will be off. So this program will not turn either of the LEDs on. Okay, Now let's learn about pulse width modulation. So pulse width modulation, it essentially provides the illusion being the keyword here. A computer cannot truly provide a true analog output. What it does do is it can only turn things on and off, ones and zeros, right? What it does do is it can turn ports on and off very, very fast, and that kind of tricks the circuit into thinking that you can get many different voltages. Remember, digital is basically you either have 0 volts or you have 5 volts for digital. With analog, you should have anything between 0 volts and 5 volts. So for analog, you can go like anything, should have anything in between for your ports. Digital is just 0 volts or 5 volts. So basically, if you look here on your Arduino, any pin that has a little tilde next to it is going to be capable of pulse width modulation. If you try and pulse width modulate a pin that doesn't have this, your program is not going to work properly. So make sure whatever you're doing, you're plugging into these ports. Okay. Let's take a look here. So this is how it works. So basically, if you're turning the port, if the port is on 50% of the time, then what's happening is, so you have like electrons flowing, so this is like your full 5 volts, but it's only on for part of the time. And so the electrons are kind of like, I guess it's kind of like evening out, so to speak. So you really are getting almost like a voltage of 2.5. It's almost like you have 2.5 volts flat. So I'm just trying to go like halfway between the peaks here. Okay. So this would be, if it was at like 50% duty on a 5 volt circuit, it's going to like appear to look like it's like 2.5 volts. 75% duty. Imagine these are like butter and they are melting down to fill the void. They would melt down to like right about here. So you're running whatever 75% of 5 is. 90% of 5, they're not going to melt down a whole lot to fill that void, just barely at all. 25% duty, if this was sticks of butter and they were melting down to fill the void, we would see it way down here, and 10% is even closer to the bottom. So you can make things, basically, if this is an LED, you can make things appear like they're barely on, but you're creating this analog with a digital port. So you're getting the port to go like really fast, or maybe the pulse is on for just a second, but it's pulsing. Okay. So pulse comes from it turning something on. Width comes from the time that it is on, and modulation just means kind of change. Okay. All right, cool. This has nothing to do with the Modulus operator, by the way. All right, so how do you control a port and tell it to turn on like this? Well, we can choose. So when you use one of the I/O pins, right, on the right-hand side, the numbered ones, you can choose to digital write. And remember, high means 5 volts. Or you can choose to analog write the pins that have the tilde next to them. Okay, so that's tilde only. So if you are analog writing, you can kind of make anything between 5 volts, but you don't plug in the voltage. You plug in a number between 0 and 255. That's what you're plugging in to create that. So basically, if you wanted 2.5 volts, you would go to effectively the halfway point between 0 and 255, which would be like 127 or something. So 127 is going to be a good spot to get roughly 2.5 volts of electricity, or a somehow equivalent of that. So what we're going to do today is we're going to get on our program, we're going to get a circuit to display basically all of the analog colors. So on the last lesson, you got an RGB LED to do the 7 colors possible with digital on, digital write. So with doing the different ports on and off. Now what we're going to do is we're going to go through the full spectrum of the rainbow. So I'm going to show a short video clip on some color theory, and then we're going to revisit that, and we're going to come back and explain that and then create the program. All right, here we go.
You sometimes hear Isaac Newton credited with discovering that you can take white light, pass it through a prism, and create a rainbow of colors. Crystals have been around forever. Rainbows have been around forever.
Doesn't this guy sound excited?
What would be more accurate is to say that he demonstrated that you can take multiple colors of light and combine them together to create white light. He went beyond that to discover that you could create white light combining together just 3 primary colors of light.
And we kind of learned this last
green,
time.
and blue, or indigo as he referred to it. By varying the intensity of red, green, and blue, he was able to recreate the entire spectrum of red, yellow to green, and the spectrum from green, cyan to blue.
So the colors we were able to achieve last week are the red, the green, the perfect yellow, the perfect cyan, the blue, and then the magenta, which we cannot currently see, but we will soon. What we were not able to achieve is colors like right here, like orange. We were not able to achieve this lime green color that's present over here. Or this kind of, I don't know what that is. It's kind of a rope. I don't know, transitioning between those two. Okay, so that's what we're going to do today. And it turns out there's a lot of colors.
These are the colors in the rainbow, usually referred to as spectral colors. People can see other colors that aren't in the rainbow. For instance, you can mix together red and blue to create magenta. He wanted to represent that as well. So he conceived of wrapping the spectrum around into a circle to create a color wheel that showed magenta as part of the range of colors that we can see. This was the first color wheel. It had all the features that we normally think of with the primary color.
Okay, there we have our RGB. Not able to achieve this kind of pink fuchsia, or really this dark, rich purple is something that we weren't able to do with the digital colors, and that's what we're going to be able to do today.
Spaced equally around, and also the complementary colors showing up opposite the primary colors.
I like that little animation that he's got. Man, that's cool. All right, so let's go ahead. Our goal here, when we're doing this today, is we're going to have our LED start. So I want you to imagine, the color wheel. Basically, we're going to have our RGB LED start at pure red, okay? And it's going to go this direction. It's going to go down through the orange, yellow, green. It's going to cycle through. Now, what's happening in that process? And then it's going to come back to where we started, okay? What's happening in that process is you are starting. So if we're talking about intensity, right? He said color intensity. If you are starting at an intensity, you have basically 3 intensity values, one for each RGB LED. So we're starting with the red intensity at full, at 255. And as we go to the right here, we're traveling to the right, we're slowly increasing the green intensity and slowly decreasing the red intensity simultaneously. So red intensity starts at full, everything else is at 0. And what happens is, as you're going to the right, slowly decreasing the red intensity and slowly increasing green. So you're going until red intensity is completely gone, and all you have is full green intensity. And then you have full green intensity and you're slowly transitioning and adding blue in and taking green away until you reach pure blue. And then you do the same thing with blue and red. So we're going to start with red. We're going to work our way to the right. And we're going to do it with one singular for loop. So we're going to get our RGB LED in Tinkercad to display a lot of colors. Now, I know what you're thinking. How many values of red intensity are there? Well, if we're going down, if we're trying to cycle through all of the colors, remember, our Arduino can think very quickly. There are 255 values for red. So the transition from red to green will have 255 values. The transition from, well, I guess 256. The transition from green to blue will have 256 values. And the transition from blue to red will have 256 values. So how many different colors are we going to be able to see in our program? Well, we just do kind of 256. I say 256 and not 255 because we're including 0. But yeah, we better go ahead and get started. 256 times 3. Okay, so let's go ahead and pull up Tinkercad. I want you to check this out. So I have like analog right here with I have my red pin plugged into port 11, even though it's not currently plugged in. I have my blue pin plugged into port 10, which is right here. My green pin plugged into port 9. So let's go ahead and change those colors, and we are going to see this thing happen. All right, let's go. So we can run this program and test. If I change my red intensity to 255, you can see, you can see it. Oh, blue is currently at 255 as well. So let's pull that off. 255 is basically digital write high. If you have it at 255, that is basically just digital write high. So let's set this to 0. We have red. Okay, cool. There's red. Now, what I'm going to do is I'm going to pull back the red, for example, to say like 30, and then we're going to turn blue on all the way. So let's pull red back to 30. We're going to turn blue on to like 255. So you can choose these color values, and there's where we get that kind of rich dark purple that we couldn't before. So this is kind of how this is working. What if I just did red at 30? What does that look like? It means we have a very low voltage running to the red. You get this very kind of pale, dim red color here. All right, cool. Let's go ahead and get this started. So how we are going to start here is we have our pin mode. We have initialized the red, green, and blue pin. We have those declared up here. What we are going to do is we are going to create an iteration variable up here for our for loop. So we're gonna have a for loop that cycles through all, and I'm going to just go from 0 to 765. We're going to go from 0 to 765, all 765 colors. Again, that's like 255. I did 255 times 3, okay? 255 times 3 is 765. We're going to cycle through all 765 colors, so I'm going to create this iteration variable. I'm going to say int color equals 0. We're going to start at 0. And 0 is going to be, we're going to use this variable color to transition and shift between all of our values. We're going to go from 0, and we're going to go all the way up to 765. And each time that we loop, we're going to increase the value of color by 1. That's pretty cool. Okay, so basically each time we loop, we're going to cycle through. So for color equals 0, it's going to be pure bright red, and then we're going to keep our transition going. And the first transition, I want to keep this image in mind, is from red to pure green. Now the entire time we are transitioning from red to pure green, we are going to have blue off the entire time. So we need variables now for our intensities. So I'm going to say int red intensity. Okay, I'm going to create 2 more variables for blue and green. Red, say green and blue. Okay, now these are going to be variables that we are going to change throughout our for loop. So at the bottom of our for loop, I'm going to analog write. Okay, I'm going to analog write. Let's see here. The red pin to the red intensity. Okay. And we can't really, we haven't defined what red intensity is yet, but that's okay. So every single loop, I'm going to come down here and I am going to change these slightly. So green, I'm going to set them and I'm going to display their colors at the end of every loop. And I want our delay to be, let's make our delay maybe like 30 milliseconds. Okay, so we're going to have a for loop that goes through and changes these values. And we're going to set red pen, green pen, and blue pen. We're going to set those values to the pin as we're changing them. Okay, so it's going to loop from 0 to 255. We are going to see it transition between red and green. So basically, I want to ignore I only want to change between red and green if it's between 0 and 255. That's the first third of all 765 colors. So we say if our value, our color, our iteration variable is less than or equal to 255, we're going to have a special transition here. Okay, let's see. All right, so what we're going to do here is in this loop, red intensity equals 0. Let's see. We want not to do that. We'll say red intensity is equal to, and then I'm going to put that in, and then I'm going to come here, copy, paste. We'll go to green. We're almost done here, and we'll go to blue. Now check this out. So I want my red intensity when it starts to be at 255. So it's going to be at 255. However, as this iteration counts up, when it goes to the second color, I want this to go down 1, and I want green intensity to go up 1. When it goes to its second iteration, I want this to have, this should be the value 253, and this should be the value 2. The entire time blue is 0. When we're looking at this transition, the blue light should not be on at all, right? It's not until we get to the next transition. So blue is, so this should be going down, and this should be counting up. And the way that we do that is we put color in for green. So on the first loop, green intensity is 0. On the second loop, it's 1, 2, 3, 4. So this is counting up exactly as it should be. This one we want counting down, which means we are going to subtract color. Now let's go ahead and run this and see what that looks like. We should see it slowly. Am I missing? Oh, missing a semicolon there. Try again. We should see it slowly kind of fade on. It's like running the old program here. Let's see. If color is 255, it's changing the intensity slowly, starting at red. There you go. And it's slowly fading to green. So starting at red, slowly fading to green, and it's stopping in green. Exactly what we want, okay? So starting at red, slowly fading on to green, and it's doing that with a delay of 30 milliseconds. If you want to make that transition a little faster, you could change this to 10, for instance, and you're going to get a faster fade between those colors. It's really pretty, okay? Now notice, make sure you're plugging into pins that have this pulse width modulation happening here. Okay, great. Almost done. Now we have to transition. I'm going to copy and paste this loop, and we're going to alter it slightly. Okay. For this one, so this is transition between red and green. There's a little comment there. This one, I want the transition between green and blue. Okay, so if we're transitioning between green and blue, red is going to be 0 the entire time. Let's see, when this starts, I want green to be the full 255, and I want it to decrease. And I want blue to start at 0 and slowly be increasing. So let's think about this. Now here what I cannot do is I cannot just put my iteration variable, because blue has to start at 0, if that makes any sense. So, oh, sorry, we need our condition. We want this to be looping while color is greater than 255, or we could say greater than or equal to 256, right? And we want it color to be less than or equal to 256 plus 255 is 511. Yep. So there are 255 values in this range as well. So we're starting at 256, and basically we want blue intensity to start at 0, and then as color goes up to 257, we want blue intensity to be 1. As color goes to 258, we want blue intensity to be 2. So what we really do here is we do color, so the value of our iteration variable, so it's done 0 through 255, we do color minus 256. Okay, and that'll get us our blue intensity. Okay, so what this does, ignore this for now, what this does, blue intensity is starting at 0, because when color is 256, subtracting 256 is 0. When it goes to 257, it's at 1. When it goes to 258, it's at 2, so on and so forth. Now the green intensity I want to be full, and I slowly want to decrease. Well, guess what? So we want it to be full at 255. We're going to subtract something that's counting up. Well, the thing that's counting up, this is counting up, right? Just like right here, color was counting up for green. So basically this minus 256 just kind of corrects for where we're at. Color was counting up here. And so what we did is, since when this was 1, we subtracted 1 here. When this was 2, we subtracted 2 here. So what we subtract is actually color minus 256. Color minus 256 is what's counting up, and we want to subtract what we're counting up from the green intensity. So green intensity is going to be decreasing. So what happens is when color is 256, that makes the blue intensity 0, which is what we want, and it makes the green intensity 255 minus 0, which is a full 255. When it counts up to 257, this becomes 1. This becomes 255 minus 1, which is 254. So this is decreasing, this is increasing. Let's go ahead and check our loop and make sure that is working. So remember, it's going to do red to green first, red to green, 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 and then it's going to start fading from green to blue, which is pretty cool. The last transition we have is from blue to purple, or blue to red, sorry. And I want you guys to try this one on your own. Pause the video, see if you can figure out what this is going to be. During the blue to red transition, you want green to be 0 the entire time. So you can go ahead and set green to 0. You can pause it right now if you want to try it on your own. Okay, so we're going to go ahead and get started. So you want blue to be at the full 255. So it's going to be 255 minus something. We don't know what that something yet is. And then we have to count up for the red intensity. The red intensity is not going to be starting at 256. It's starting at 512. And it's going up to that 756. So we can just say, well, color is greater than or equal to 512, which would be the starting point. So here's 511, there's 512. The red intensity is going to slowly be fading in, so it's going to start at 0 and count up. If it's 0 at 512, we want it to be 1 at 513, and so on and so forth. So we do color minus 512 here. And then down here, this is counting up, color minus 512, because 512 is 0, 513 makes this 1, 514 makes this 2, so on and so forth. So then we're subtracting from 255 here, which would be color minus 512. So now we should see the full transition between all 765 possible colors for a pixel. Here we go. Transitioning to blue, purple, and then back to red, and the loop starts over. Well, team, that's it. Thanks for watching. This has been a Mr. Schlegel's Mathnasium video. Hopefully this sample program made sense. Take a look at the sample exercises, and thanks for watching.